Today's honors geometry lesson is on section 6.4, the tangent ratio. The objectives are to define tangent and to use the tangent ratio to find the missing sides and angles of a right triangle. The word trigonometry comes from the Greek words that mean triangle measurement. In geometry, we will specifically cover the trigonometry of right triangles only. In the right triangle shown below, we have one acute angle that is marked, which is angle A. We also have the leg opposite this angle and the leg adjacent to this angle labeled as well. So if you look here, we have adjacent angle A, the side opposite angle A is this side here, and the side adjacent is right here. Many people have difficulty identifying the adjacent leg, so here is a strategy. I think the easiest side to identify in a right triangle is your hypotenuse because it's always opposite the 90-degree angle. So first label your hypotenuse. The second easiest side is to find the leg that is opposite the angle. So in this case, again, here is our leg opposite angle A. Then by default, the side that you have not marked must be your adjacent leg. So if you ever have difficulty determining which leg is the adjacent, identify your hypotenuse, then identify your opposite leg, and then you can identify your adjacent leg. The following ratio of the lengths of the legs is called the tangent ratio. We can say that the tangent ratio of angle A is always going to equal the leg opposite that angle over the leg adjacent to that angle. So let's take a look at example 1. We want to find the tangent ratio of x and the tangent ratio of y. So remember from the previous slide that the tangent of any angle, okay, so in this case we're going to look at angle x right here, is going to be equal to the leg that is opposite over the leg that's adjacent. So for the first part of the example, if we look at the hypotenuse, again, if we're having trouble labeling, the hypotenuse is going to be opposite the 90-degree angle. The second side that we're going to locate is going to be the side that is opposite. Here's your opposite side. So by default, this side down here is going to be your adjacent side. So now if we set up our tan ratio for x, we know that the tangent of angle x is going to be equal to the opposite side over the adjacent side. So the opposite side has a value of 12, and the adjacent side has a value of 5. For tangent y, we're going to follow the same ratio. So we're going to find the tangent of angle y is going to be equal to the side that's opposite over the side that's adjacent. So for this example, the hypotenuse is still going to stay the same. It's going to be the side that's opposite the 90-degree. However, if we look at angle angle y, which is here, the side that is now opposite angle y has a length of 5. Therefore, the side that has a length of 12 is now going to be our adjacent side. So the tangent of angle y is going to be the opposite over the adjacent side, or the value of 5 over 12. Let's go ahead and use the tangent ratio to find some missing side lengths of a right triangle. For this, you're going to need your graphing calculator, so keep that handy. The first thing we're going to do is to go ahead and set up our ratio that we can use to find the value of y. So most importantly, locate the acute angle, locate all three of your sides in relation to that angle. So this side opposite the 90 degrees, your hypotenuse. For this example, y is your side that is opposite, which makes this side down here your adjacent side. So in this case, when we set up our ratio, we're going to have the tangent of our angle. So this time we don't have a variable or a letter for an angle. We actually have a degree measure. So the tangent of 56 degrees is going to equal that opposite leg, which is y, over the adjacent leg, which is 32. Then from here, we just go ahead and solve our equation. So in order to get y by itself, we're going to have to multiply both sides by 32. Okay. So in our calculator, we're going to be able to take 32 times the tangent of 56, and that's going to give us our value for y. So let's go ahead and bring up our graphing calculator. The most important thing when working with sine, cosine, and tangent, or your trigonometry ratios, is to make sure your calculator is in degrees. So if you go into your mode key, which is to the right of your second, you're going to want to go down to radian, click over to degree, and hit enter. So you want to make sure that degree is actually highlighted. Then from here, we can go ahead and start finding our value for y. So we're going to type in 32. We're going to hit the tangent key, which is to the left of the caret. We're going to type in 56, close our parentheses, and then we can evaluate by hitting enter. So to the nearest tenth, the value of y is going to be 47.4. Taking a look at the second example, we're also going to find the value for y. So as before, you want to go ahead and make sure you locate your acute angle, label all sides, so the side opposite the 90 degrees, your hypotenuse. This is going to be your opposite side, so a value of 27. And in this case, y is going to represent your adjacent side. So if we start setting up our ratio, we're going to take the tangent of the acute angle of 50 degrees. We're going to set that equal to the opposite side, which is 27, over the adjacent side, which is y. Now, when you're solving for y, you want to make sure you follow your rules for solving equations. So in order to get y by itself, we first have to bring it out of the denominator by multiplying both sides by y, which leaves us with y times tangent of 50 degrees is equal to 27. So if we have y times the tangent of 50 degrees, to undo multiplying by tangent of 50 degrees, we're going to divide by tangent of 50 degrees on both sides. So in our calculator, we're going to find y by taking 27 times the tangent, 27 divided by the tangent of 50 degrees. So if we bring up our graphing calculator, we're going to want to take 27 divided by your tangent of 50 degrees, and we're going to round this to the nearest tenth. So the side length of y is going to be approximately 22.7. We can also use the tangent ratio to find degree measures. So in a right triangle, if we are given the opposite side and the adjacent side of an unknown angle, we can use what's called the inverse of tangent to find that degree measure. So in this triangle, we have angle Z with an opposite side of 4 and an adjacent side of 3. So if we set up our tangent ratio, we're going to have the tangent of our unknown angle Z is going to be equal to the opposite side, which is 4, over the adjacent side, which is 3. So in our calculator, in order to go from the side length back to an angle measure, we're going to have to take the inverse function. So in our calculator, to get z, we're going to take the inverse of tangent, and we're going to multiply that by the ratio of 4 to 3. So the notation of taking the inverse is tan to the negative 1. So this is what we're looking for when we plug this into our calculator. So if we go to our graphing calculator, I'm going to show you where the inverse is. If you hit your second key and you hit the tan button, that tan to the negative 1 goes to the screen, and then we simply have to put in our ratio of 4 divided by 3. And when we hit enter, we now have the degree measure. So to the nearest degree, angle Z is going to be 53 degrees. So let's take a look at one more example using the inverse of tangent. So in the second example, we're trying to find acute angle Z. This is our hypotenuse. So this time the side opposite is going to have a measure of 5, and the adjacent side is going to have a measure of 12. So setting up our ratio, we're going to have the tangent of angle Z is going to equal the opposite side of 5 over the adjacent side of 12. So in our calculator, we're going to find Z by taking the inverse, which is our tan to the negative 1, of the ratio 5 to 12. So if we go into our calculator, we're going to bring up the inverse of tangent by hitting second tangent key, typing in our ratio of 5 divided by 12, and hitting enter. So now we know that Z to the nearest degree is going to be equal to about 23 degrees. This is the end of our lesson on the tangent ratio. If you have any questions, watch the video for a second time. And if you still have questions, write down those clarification questions and bring them to the next class.